All right, today we are talking about something truly fascinating, a security framework that uses blockchain and NFTs to solve a problem that sounds like it's straight out of a movie. It really all boils down to one single question.
So, how do you do it? Seriously, think about it. In our super connected industrial world, this isn't just a thought experiment. It's a massive everyday challenge. Factories need outside experts for things like predictive maintenance, but giving them access to your most critical digital systems? That's a security nightmare waiting to happen. How do you hand over the keys without risking the entire operation?
To really get what's at stake here, we need to understand the world we're operating in. We're talking about the Industrial Internet of Things, or IIoT, where all the physical machines and the digital software are completely tangled together. And right at the heart of all of this is an incredible concept called the digital twin. So what is a digital twin? Well, imagine a perfect one-to-one virtual copy of a robot out on the factory floor. And I don't just mean 3D model. This thing is a living blueprint, constantly getting real-time data from the actual physical robot. It lets you monitor its health, you can simulate tasks on it, and you can even predict with incredible accuracy when a specific part is about to fail. And what you're looking at here is that constant two-way flow of information that makes this whole thing so powerful. You've got the physical factory on one side, with its robots and sensors just constantly streaming data to its virtual replica, the digital twin. And in return, all the insights and analysis from that twin can be sent right back to optimize and control the real robot. It's this beautiful, powerful feedback loop. And this is where we hit our dilemma. Let's say a specialized maintenance company needs to tap into that digital twin to run its fancy predictive analysis software. They have to get that access to do their job, right? But you can't just email them a password to your entire system. I mean, no way. That throws the door wide open for data theft, industrial espionage, or even someone sabotaging the physical robot itself. So you might be asking, why can't we just use the security methods we've always used? Well, it turns out that in this new world of smart manufacturing, those traditional security models aren't just a little bit outdated. They are dangerously, fundamentally broken. You've basically got two ways of thinking about this. On one side, you have the old school centralized model. Think of it like a giant medieval fortress with one big gate and one all-powerful gatekeeper. And on the other side, you have a decentralized model, which is more like a whole network of trusted checkpoints where there's no single point of control to attack. And the problem with that big fortress is kind of obvious, right? If that one gatekeeper gets compromised or just goes rogue, the entire kingdom is exposed. It creates a massive single point of failure. A malicious insider can cause unbelievable damage. All your data is sitting in one place, which makes it a huge, juicy target. And frankly, forcing every single request through one central server just slows everything down. And this is where things get really interesting. This new framework comes in and just completely tosses out that old centralized model. Instead, it builds an entirely new system of trust from the ground up, using a modern, decentralized approach. The solution really has three key ingredients. First up, there's a private, decentralized blockchain network that basically acts as the unchangeable, shared rulebook for everybody involved. Second, it uses something called platform verification to prove a device's identity is legit. And third, and this is super cool, instead of passwords, it uses NFTs, non-fungible tokens, as these temporary single-use digital keys. You know, the whole core idea is summed up perfectly right here in this quote from the research. By using a distributed blockchain, you get rid of that single point of failure. Trust isn't in one company or one server anymore. It's mathematically spread out across the whole network, which makes the entire system just incredibly resilient. Okay, so that all sounds great in theory, but how does it actually work? Let's walk through the whole process. Think of it as a secure digital handshake that happens literally in the blink of an eye. It's a really elegant sequence. Okay, step one. It all starts when a technician from that outside maintenance company needs to get into the robot's digital twin. So they send a secure access request into the network. Now, that request doesn't just go to some central server. Instead, a smart contract, which is just a self-executing program on the blockchain, broadcasts the request to every single organization on the network. You can think of it like a digital town crier, announcing the request to everyone at the same time. Now, here's the really clever part. Only one organization on that network can actually vouch for that user, their own company, their home domain.
Their system confirms the user's identity, and crucially, it checks that their device hasn't been tampered with. It does this by verifying the device's platform hash, which is basically a permanent, unfakeable digital fingerprint. Right, so the user's home domain sends that verified digital fingerprint back to the smart contract. The contract then does a simple comparison. Does this verified fingerprint perfectly match the one from the original request? If they match, boom, that's proof. The user is who they say they are, and their device is secure. At that exact moment, the contract instantly mints or creates a brand new NFT. And this NFT, this is the digital key. It's sent straight to the user, and it gives them super specific temporary access. It's like giving someone a key that only opens one specific door for only 10 minutes and then turns to dust. It's a security concept called the principle of least privilege, and it means you're only ever exposed for the absolute minimum amount necessary. So this is all very slick technology, but does it actually perform in the real world? And what's the actual impact? Well, the performance numbers from the research are pretty stunning. That entire secure handshake we just walked through, from the first request to getting the NFT key in hand, takes about 300 milliseconds. That is literally less than the time it takes you to blink. In a factory where every minute of downtime costs thousands of dollars, that kind of speed isn't just nice to have, it is absolutely essential. And it's not just fast in a vacuum. When you compare it to other similar decentralized frameworks, this system is a jaw-dropping 67% faster at figuring out who a user is. That level of efficiency means less waiting around, faster maintenance, and way smoother collaboration between different companies. The security upgrades are just as impressive. You can see here how the new framework stacks up against old centralized systems. Because trust is spread out and every device's digital fingerprint has to be verified, the new system is incredibly tough against things like impersonation or spoofing attacks and even insider threats, all areas where those old centralized systems are just notoriously weak. So what's the big takeaway here? At the end of the day, this framework rips out the single point of failure and replaces it with a distributed network of trust. It swaps out vulnerable, permanent passwords for temporary, single-use digital keys. It proves that you can build a system that is both way more secure and way faster. Which really leaves us with one final question. Are we looking at the new gold standard for how we secure the future of our most important industries?